Welcome back to another Forge College Explainer. Honestly, I am absolutely thrilled to guide you through this because we've reached a massive, groundbreaking moment in our full migration project from the EVM to the SVM. Today is the day all of that careful theory finally turns into a real, tangible working environment. We're taking those abstract plans we've mapped out and building a brand new Anchor workspace, one that's going to feel just as comfortable and reliable as your old Ethereum setup.
All right, let's look at our master blueprint for today. We'll hit exactly 5 things. 1. The parity principle. 2. Scaffolding your workspace. 3. Building the foundation. 4. Wiring the local net. And finally 5. Deploy and verify. So before we pick up our digital hammers, we have to stop and answer this. Why on earth did we just spend hours meticulously creating a migration audit in our previous lesson? Well, we start here because moving from the EVM to the SVM is literally like moving to a new house. That audit from our last lesson, that's the exact blueprint we need to arrange our new home so we can actually find our tools in the dark. Without it, you'd be packing your toothbrush in the exact same box as your power drills. Your audit gave us a concrete inventory of compiled JSON artifacts, ABIs, and deployed addresses. Keep that inventory handy, guys, because it's the master key for literally everything we're going to do next.
Okay, diving right into Section 1, the parity principle, translating developer workflows. Now, the absolutely crucial point to understand here is that environment parity isn't just about making your Rust files compile. I mean, anyone can make code compile eventually, right? Usually after way too much coffee and staring at endless red error logs. No, true parity is about perfectly mirroring your old Ethereum setup in Anchor so that everything just feels like home. We are meticulously recreating your developer ergonomics. When your team types a command, or when your continuous integration pipeline goes hunting for a build artifact, it shouldn't crash and burn just because Solana handles things a bit differently. The ultimate goal is a completely seamless translation of the workflow you already know and trust.
Moving on to Section 2, scaffolding your workspace, unpacking the boxes. Let's get to work.
You'll want to begin by opening up your terminal and running this beautifully minimal initialization command, anchor init, followed by your project name, and then that -- JavaScript flag since we're setting up a testing environment. Now, please pay close attention here. You've got to make sure you use a program name that corresponds exactly to an entry from your migration audit. If your audit mapped mytoken.sol to a program called my_token, you use that exact naming. Don't just wing it and make up a new name on the fly. Otherwise, you're going to completely lose the thread connecting your old world to your new one. And you know, this brilliantly illustrates our very first rule: immediately replace Anchor's default naming with the exact folder and file names from your old Hardhat layout. Out of the box, Anchor's going to generate some default directories for you. Your job is to go right in there and rename them so the paths your CI scripts and your developers expect remain totally familiar. We want zero friction here, and keeping your naming conventions identical is hands down the easiest way to achieve that.
All right, Section 3, building the foundation, generating artifacts. Just run the Anchor build command in your terminal and step back to watch Anchor work its magic. It's going to compile your Rust program and automatically generate 2 incredibly important things for you. First, your compiled shared object file, that's the one ending in .so, tucked inside the target/deploy folder. And second, your IDL, or interface description language file, safely inside the target/IDL folder. These 2 things right here, these are the actual physical bricks of your brand new Solana application. Now, take a look at this. Let's map your old EVM paths directly over to their new SVM equivalents. Look at that very first row. Your old Hardhat JSON artifacts? Those are now your Anchor IDL JSONs. And remember, the IDL completely replaces your old ABI for client code. It is the absolute authoritative schema for exactly how your client talks to your program. Notice too how your deployment scripts and your test folders map over perfectly. You can basically think of this table as your ultimate translation dictionary.
Up next is Section 4, wiring the local net, powering up.
Okay, so you're going to create a super small helper bash script. Let's just call it localnet_start.sh. Now, this script's job is to launch the solana-test-validator. But listen, we aren't just casually turning it on. We are specifically feeding it flags like --reset and --bpf program. Why? To ensure it provides the exact same predictable, highly deterministic state that your old Hardhat tests are expecting. We want our local Solana node to act like a perfectly controlled laboratory environment that resets completely clean every single time. Notice the simple 3-step flow. Build your code, start the localnet validator, and deploy the program. This completely, and I mean completely, replaces the old npx Hardhat node followed by a localhost deployment pattern that you're probably used to. It's the exact same rhythm, you're just playing it on different instruments now. Honestly, once you script this sequence out, your developers probably won't even notice the underlying technology has changed.
To ensure all of this connects flawlessly, you only need to update 3 very specific places. First up, grab your generated program ID right from the key pair file located in target/deploy. Second, paste that ID directly into the programs.localnet section of your Anchor.toml file. And lastly, update that localnet-start.sh script we just made to point to your freshly compiled .so file. Bam! That's it. Now Anchor knows exactly which compiled program to point to and exactly where to put it.
Finally, we reach Section 5, Deploy and Verify, the inspection.
Running this incredibly straightforward command, anchor deploy --provider.cluster localnet, is going to deploy your compiled program directly to the localnet validator you just started up. If this executes successfully, take a deep breath and pat yourself on the back, because that's a massive milestone. It confirms the entire loop, from your Rust source code through the compiler, all the way to the local blockchain, is fully functional and actively talking to each other.
But in Web3, we don't just guess, we verify. You want to rigorously check off every single item on this verifiable list to definitively prove your environment parity is a total success. 1. Did the build actually exit with status 0? 2. Is the validator actively running in the background right now? 3. When you run Solana program show, does it actually find your program? And 4. Does running anchor test --skip deploy pass a basic smoke test? We use skip deploy here because, well, we quite literally just deployed it. If all 4 of those are green, you officially pass the inspection.
So, the grand takeaway here is perfectly captured in this single principle. By honoring developer ergonomics and making your artifact mapping from the EVM over to the SVM completely explicit, you ensure that both your human team members and your automated CI pipelines experience absolutely minimal friction during this major transition. You're setting the stage for long-term success rather than fighting your own tooling every step of the way. Now that we have our environment perfectly mirroring our old setup, a huge question remains. How will your newly matched IDLs actually handle the stress of full integration testing? Well, that sets us up perfectly for our next lesson, where we'll dive into porting your actual tests and simulating those complex local interactions. But until then, please head over to forge.college to dive even deeper into this explainer, grab all the starter scripts we discussed today, and continue mastering your Web3 migration journey. Thank you so much for joining me on this Forge College explainer. Happy building, and I'll see you in the next one.